afternoon to one and all. This is K. Pushpa Rani, Associate Professor, Department of CSE, MLR Institute of Technology. In this video, we are going to discuss about logical inference. What is meant by logical inference and what are the methods to solve whether the conclusion is true or false, or the conclusion can be derived from the set of premises or not. That we can define with the help of the logical inference. So, what we are going to discuss, what is logical inference, what are the methods to solve the logical inference. One is there are two methods to solve the logical inference. One is a truth table method. Another one is by applying the rules of inference, we need to derive the conclusion. So, in this video, we are going to discuss about what is logical inference, and also we are going to discuss about what is a truth table method. So, first of all, what is the definition of logical inference? Logic. How to derive the logic? With the help of some set of rules. If the set of rules can derive the conclusion from the premises, then it is called as a logical inference. What is the definition? The logic is derived from the set of rules. These set of rules are called as a premises. These set of rules are called as premises. These set of premises can be applied to derive the conclusion. Then the logic is said to be logical inference. The theory associated with the set of premises or rules of inference is called as inference theory. Now, here the term called premises. What is meant by premises? Premises are some rules. What type of rules? That may be equivalent laws, or it is a identity laws or associative law, whatever the rules. We are going to apply the rules to the logic to derive the conclusion. Then it is called as a logical inference. The word inference can be derived by applying the set of premises. These premises are conjunction of premises. For example, premises is P1, P2, P3. What the premises consisting of? The premises consisting of a set of statements. The statement may be either variable or it is a negation of variable. This is one premise. Then conjunction. For all this thing, we are going to take the conjunction. These conjunction of premises derive the conclusion. Conclusion also one type of statement. What the statement consisting of? The statement consisting of either variable or it is a negation of variable. From these set of premises, if the conclusion is derived, then this is a valid inference. If the conclusion is not derived, then it is called as a invalid inference. So, what the conclusion? The conclusion may be either valid inference or it is a invalid inference. How the conclusion can be derived? By applying the set of premises. What is meant by premise? Premise may be either a variable or it is a negation of variable. That set of premises, we are going to take the conjunction of premises. That conjunction of premises can derive the conclusion. Then the inference is said to be a valid inference. So, we are going to show the methods whether the inference is a valid inference or not. So, what is the set of formulas? A1, A2, A3, AN. These are the set of premises. Okay, these are the set of premises. And the conclusion can be considered as a P. B is a conclusion. The set of premises are A1, A2, A3 and so on AN. This conjunction, that means we are going to take AND operation between the set of premises, that is A1 then and A2 and A3 and so on AN. This set of premises implies means it is a conclusion. Conclusion may be derived from the set of premises. This entire statement derives a tautology in the truth table method. Then we can call it as a valid inference. But by applying the rules of inference, the conclusion is the final step, then it is a valid inference. But when I am coming to the truth table method, the total set of premises implies the conclusion B. The entire set of premises derives the conclusion as a tautology. Then the statement is said to be a valid inference. Otherwise, it is a invalid inference. There are two methods to determine whether the conclusion is logically follows from the set of premises or not. So for that reason, we are going to use two methods. One is a truth table method, another one is a rules of inference. What the truth table? The truth table, the last column of the truth table should be a tautology. Then it is a valid inference. If the conclusion is not a tautology, that may be either contradiction or it is a contingency, then in two cases the inference is an invalid inference. Either it is a contingency or it is a contradiction. Okay, only if it is a tautology, then only we can say that it is a valid inference. For the remaining cases like a contradiction, or contradiction means the last column of the truth table contains false values, then in this case this is an invalid inference. Or some values are true, some values are false in the truth table, then also in that case also we can say that it is an invalid inference. Let us discuss about the first method, that is a truth table method. What is the conclusion? What are the premises? Whether the conclusion is valid or not, we can understand by taking the example. Show that a conclusion C follows from the premises H1, H2. Here H1 is one premise, H2 is another premise. What is H1 consisting of? A negation of P. What is the second premise? P or Q. P or Q is the second premise. What is the conclusion? Q. From these two set of premises, we need to derive Q. So, but what is the conclusion? The conclusion is Q. But how to check whether it is a valid inference or not? Take the two conclusion, that is H1 and H2 is C. Then H1 and H2 derive C is a tautology. Then it is a tautology. The total outcome is a tautology. Then it is a valid inference. For that reason, we need to derive the conclusion. First preposition or first premise is negation P. Second premise is P or Q. And conclusion is Q. For the entire set of premises, we need to apply the implication for the set of premises. Then we need to observe the last column of the truth table. P, there are two premises are given. The two premises contains only two prepositions like P and Q. Then total number of rows in the truth table is 2 power 2. That is 4 rows are present in the truth table. That is true, 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 false, false, true and false, false. Take the negation P. Negation P is nothing but the opposite of the preposition. That is a P. False, false, true, true. P or Q. Then P or Q is a take or operation. It returns true value if both premises are either true or it is a false. If both prepositions are false, then only it returns false. For the remaining cases, it returns as a true only. That means P or Q, true, true, true only. Then true, false, true only. Then false, true is true, false, false is false. Again, negation P and P or Q. For these two statements, you need to apply the AND operation. AND operation returns true when both conditions are true. Otherwise, it returns as a false. That means false true is false only. False true is false only. Again, true true is true. And true false is true. Again, how to derive the conclusion? Take the entire statement implies Q. We need to apply the operator called implication. For the conclusion derivation, we need to apply the operation called implication. That is negation P. We know the value of all these things. False then true is true. True, false, only it returns false. For the remaining cases, it returns as a true value. False, true. Again, false, false is true. True, true is true. False, false is also true. Observe the last column of the truth table. The last column of the truth table is a tautology. Then we can say that this conclusion is derived from the set of premises. Then it is a valid inference. When we can say that valid inference, if the conclusion is derived, how can we say that it is the conclusion can be derived? The last column, the implication of the set of conjunction of premises derives the conclusion, derives a tautology, then we can say that it is a valid inference. We can take one more example to understand whether it is a valid inference or it is a invalid inference. Take the second example. What are the set of premises? There are two set of premises are there. First one is a H1 P implies Q. H2 is a negation P. And what is the conclusion? The conclusion is Q. What is step number 1? Set of premises. Take the conjunction of premises. What is the conjunction? P implies Q and negation P derives the conclusion. That is step number 1. Then what is step number 2? The total entire statement is a tautology. That is the main aim of the deriving of conclusion. For that reason, we need to derive the conclusion. We need to write the construction of truth table. PQ, P implies Q. So, PQ returns, P implies Q returns false. The first statement is true. Second statement is false. For the remaining cases, it returns as a true value. Again, take the negation P. What the negation P returns? Negation P returns a opposite of P. If both values are true, it returns as a false. If both values are true, it returns false. If both values are false, it returns as a true value. If it is true, it returns false. If it is a false, it returns true. Again, P tends to Q is already derived. Take AND operation between P implies Q as well as negation P. For these two things, we need to apply the AND operation. True, false is a false value. True, false. That means AND operation returns true. Both conditions are true. Otherwise, it returns as a false. Then true, false. Again, false, false. True, true is true only. True, true is true only. Then this is the statement. But our aim is we need to derive the conclusion. For this reason, we need to take the conjunction of premises. These are the conjunction of premises. Then conclusion. For these two things, we need to apply the implication rule. That means P tends to Q and negation P to Q. False, true is true only. Again, false, false is true only. True, true is true only. Then true, false is false only. Then observe the last column of the truth table. In the case of the last column of the truth table, does not contain tautology. It does not contain the tautology. Some values are true, some values are false. Then it is called as a contingency. But what is the condition for the valid conclusion? The last column of the truth table must be a tautology, then only it is a valid inference. But some values are true, but the last column is not a true value, so it is not a valid inference. So what is the conclusion? It is not a valid inference. That means we can't derive the conclusion from this set of premises. Take one more example for better understanding of the rules of inference. Okay, take the only one preposition, that is only one premise, that is H1, P derives Q. And what is the conclusion? P implies P and Q. Then take the conjunction of premises. Here we are not going to take any conjunction of premises because only one premise is present. Take the entire statement P implies Q, derive the conclusion. We need to show that it is a tautology. So by default, it consisting of only two statements are present in the preposition. Then total number of rows in the truth table is 4. 4 rows. Okay. Take 4 rows, true, 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 false, false, true, false, false. P implies Q. P implies Q. P implies Q returns false. First statement is true, second statement is false. That's why it returns as a false. For the remaining cases, it returns as a true value. Then P and Q. P and Q returns true if both conditions are true. Otherwise, it returns as a false value. True, true, true only. For the remaining cases, it returns as a false value. Next, P implies P and Q. Take the conclusion. P implies P and Q. We know what is P and Q. For these two statements, we need to apply the implication. P implies P and Q. True, then true. It returns as a true. Then true, false is a false. False, false is a true. Then false, false is a true. For this statement, it is the implication. Now, apply the entire set of statement that derive the conclusion. That means P implies Q implies P implies P and Q. What is P implies Q? That is a true. What is P implies P and Q is true. If both are true, it returns true. It returns true. Next, second one is false and second statement is also false. Both are false, it returns true in the case of implication. That is true only. Next, true, true is true only. Next, true, true is true only. Observe the last column of the truth table. The last column of the truth table consisting of a all values are true. The conclusion is a tautology. If the conclusion is a tautology or the set of premises derives the conclusion is a tautology, then we can say that it is a valid inference. So, we are already what we have discussed up to now. What is meant by logical inference? What are the methods to solve whether the inference is a valid or not? There are two methods are there to check whether the inference is valid or not. One is a truth table method. In the case of truth table, we are going to take the conjunction of premises. That conjunction of premises derive the conclusion is a valid inference. The last column of the truth table derives a tautology. Then only we can say that it is a valid inference. Suppose some values are true, some values are false, then it is not a valid inference. But suppose if all values are false, then only we can say that it is a invalid inference. That is about the logical inference. Now let us discuss about the second method, that is a rules of inference, in the next video. Thank you.